Hi, we are from Group 4D and today we're gonna talk about battery concepts and its application. The galvanic cell produces energy through the transfer of electrons. This chemical process includes two parts consisting of an oxidation and a reduction process. Oxidation is the process of a chemical substance losing electrons. Reduction is the process of electron gain in a chemical substance. Within a galvanic battery cell, there are electrodes which are the sites to facilitate electron transfer. The electrodes consist of two parts, the anode and the cathode. Oxidation occurs at the anode, whereas reduction occurs at the cathode. The anode basically sends the electrons over to the cathode to complete the reduction, having the anode itself oxidized. Once it is completed, a voltage can be measured across the cell using a voltmeter. The cell potential is also called the voltage or the electromotive force of the cell. The formula is as follows: E cell equal to E cathode minus E anode. A galvanic cell derives its electrical energy from the spontaneous redox reactions taking place within the cell. The spontaneity occurs when the value of E cell is greater than 0. To put it simply, the E half cell value reflects how strongly whether the reactant acts as an oxidizing agent or as reducing agent. The reactants that lies below in the EMF series will then undergo electron transfer and release energy.
Here are some examples of the application of the electrochemical process. Batteries. Batteries are mainly categorized as primary, one-time uses batteries, and secondary, can be recharged and used again. Most of them consist of various toxic metals, which are both hazardous to the environment and also to human health. Thus, disposal of batteries have a paramount importance in the eyes of manufacturers and recycling organizations. Unfortunately, the most cost-efficient and fastest way to deal with this dilemma is to send the waste to landfill. Another application is lead-acid battery. It contains sulfuric acid and large amount of lead. The acid is extremely corrosive, but is a good carrier for soluble lead and lead particulate. Lead is a highly toxic metal that produces a range of adverse health effects, ranging from damages to the brain and kidney, impaired hearing, and can lead to numerous other associated problems. Last application is lithium-ion battery. It uses cathodes with nickel and cobalt, as well as solvent-based electrode processing. Lithium-ion batteries are at the highest risk for negative health and environmental impacts. These impacts are the result of the production, processing, and use of cobalt and nickel metal compounds. The environmental impacts include resource depletion, global warming, and ecological toxicity. On the other hand, poor respiratory and neurological effects are some examples of the health effects. Thank you.